So in electrochemistry, we're gonna focus on mainly two things. It's gonna be uh, the redox half reactions, the redox reactions, in which you're gonna need to know the redox half reactions. You're gonna need to know what is an oxidizing agent and a reducing agent. From this, you're gonna need to be able to identify identify a cathode and anode, and you're gonna need to be able to calculate the cell potential of a galvanic cell. So usually in electrochemistry, these are the things that we're gonna focus on. So let me just give you an example. So first, let's discuss the redox reactions. So I'm just gonna give you an example of like Cu2 plus. It's gonna be added by 2 electrons. This is gonna give you copper, which is a solid. And this is in an aqueous phase. So basically, this is a redox half reaction, and each half reaction has its own cell potential. Where you're gonna have, I think, the EO is equal to positive 0.34 volts. So this is actually redox half reaction. So I think from grade 11 work, you guys know what oxidation is and reduction is. Am I right?
Yes, sir.
Okay. So usually in a redox half reaction, you're gonna have this, then you're gonna have a second equation, let's say zinc 2 plus, which is also at an aqueous phase. This is gonna be added by 2 electrons. it's gonna give you Z, which is a solid. Let me just open your formula sheet real quick. Terminal, so yesterday on Sunday, you guys were supposed to write a test, but unfortunately, like I did not send it to you. So if it's not a problem, can I send it to you? Then I'll give you like 2 hours to write it, and then you can send it back to me.
Now, sir.
I'll send it to you after the class, then I'll give you 2 hours to write it. You send it back to me so I can be able to compile your report and send it to Clement.
Okay, sir.
Okay, so I'll send it to you, then before 9 p.m. you just send it back to me so I can compile your report very quick.
Okay, so what's the test about?
Basically everything we did in class, just me for us.
Okay.
Yeah. So I think we did, what was that? We did we, we did chemical equilibrium and KC. We did which other one was that? Let me just check it for you real quick. We did electric circuits and we did generators and motors. I think those are everything that we've done. Let me just see. Can you see the document that I've opened, or should I try to share my screen again?
I can't see it, sir.
Okay, let me just new share my screen. You can see it now.
Yes, sir.
So basically this is the standard potential table. So every question with regards to the redox reaction and electrochemistry, you're gonna need to use this table. So as you can see, I was making an example with copper here. It's copper and 2 electrons. Oh yeah, sorry, copper and 2 electrons. 0.34. Yeah. Then this is the one for copper. Let me just highlight it. Then I was looking for the one for zinc, which is here also. So those are basically the equations that you're gonna use. Let me go back to that whiteboard and see. So you can see the whiteboard now. So the electric potential of this is negative 0.76 volt. So I'm pretty sure you can see the whiteboard now. So in this situation, you can see that the value of the standard potential of copper is greater than the value of the standard potential for zinc. So if these two metals were to be used in an electrochemical cell, a galvanic cell, that means copper, since it has the higher electric potential, that's gonna be your cathode. So copper is gonna be the cathode. And zinc is gonna be your anode. Just because of these signs, because zinc is negative and copper is positive. So zinc is gonna be your anode. Do you understand so far?
Yes, sir.
So since we know that zinc is gonna be the anode, we have to relate our cathode and anode to the oxidizing and reducing agent. So our cathode, that's where reduction occurs. So for the cathode, reduction occurs. So copper is gonna be reduced. Let me just erase this. Copper is gonna be reduced. And in our anode, that's where oxidation occurs. So zinc is gonna be oxidized. So by definition, we know that the one that is oxidized, it causes reduction to occur in the one that is reduced. So basically, since zinc is gonna be oxidized, copper is gonna be reduced. So since zinc causes copper to be reduced, it's gonna be our reducing agent. And from that, we also know that copper is reduced because zinc is oxidized, meaning copper causes zinc to be oxidized. Thus, our copper is going to be our oxidizing agent. So you just know that the cathode is the oxidizing agent and the anode is the reducing agent. The cathode is reduced and the anode is oxidized. So I think that's a more nice way of putting it. So do you understand it?
Yes, sir.
So let's say now we're gonna have a cell, a galvanic cell. So in order to construct a galvanic cell, you're gonna need two beakers. So in this, let me just change the color. So in this, let's say we have our copper solution. And the other one, let me just choose a different color. We're gonna have our zinc solution. So most of the time, our copper solution is usually Cu SO4. So in our zinc solution, just check for you real quick. For the zinc solution, it's usually zinc, zinc nitrate. So ZnNO3 2. So since we have these solutions, we're also gonna have a metal. So we're gonna have a copper metal here and a zinc metal here. Which line can I use to draw a wire? So we're gonna have one wire connected here and another one connected here. And here is gonna be our voltmeter. So get it or something like that. So the voltmeter is to read the electric potential of the cell. And in addition to the voltmeter, we don't want our action to reach equilibrium. So we're gonna have a salt bridge so that the reaction never reaches equilibrium. So this is gonna be a salt bridge. So this is the basic structure of a galvanic cell. Let me just go back to that. Where you're gonna have your two solutions. The metal that's gonna get, this is the copper metal, which is gonna get reduced. So this is gonna be a Cu. And the zinc metal, which is gonna get oxidized. So this is gonna be a Zn. So I think for now that's everything. And you need to know how to calculate the cell potential of the cell. So your E cell is equal to E cathode minus E anode. So do you understand everything?
Yes, sir.
So there's two ways to identify the cathode and anode. The first one, you just look at these signs. If it's negative, it's the anode, and if it's positive, it's the cathode. But you can also, let me just share my screen again. But you can also look at it from here. Just from this table. So you can see a copper is down here. So copper, in most situations, when it's in a cell with maybe, let's say iron, right? So if it's gonna be in a cell with iron, that means since copper is lower on the table and iron is higher on the table, copper is your cathode and iron is gonna be your anode. You understand that?
Yes, sir.
Yeah, so when it comes to situations where the standard reduction potentials are both positive, the one lower on the table is your cathode and the one higher on the table is your anode. Because in such situations, let me just go back to the whiteboard. In such situations where we have let's say Fe3 plus an electron. Sorry, let me just do this on another page. Clear everything. Clear all my drawings. So now let's say you have a cell with Cu2 plus, two electrons, giving you Cu, which the electric potential is gonna be equal to 0 positive 0.34 volt. And you have Fe Fe3 plus an electron, giving you so in this situation, since we know that copper is our cathode, that means copper is gonna get reduced. So we're gonna leave the equation like this as it is on the table. But since iron is our anode and it has to be oxidized, this is a reduction half reaction. So we have to change it to an oxidation half reaction. So for the oxidation half reaction, we're gonna have Fe2 plus giving us Fe3 plus an electron. So it went from a reduction half reaction to an oxidation half reaction. So since you can see the reaction now is now backwards, the cell potential, I'm sorry, the standard cell potential is gonna change. The sign will no longer be positive. It's gonna change into negative. You understand that part?
Yes, sir.
Yeah, so after that, we're gonna calculate our cell potential, where E cell is gonna be equal to the cathode minus the anode. Let's erase this. So that's gonna give us 0.34 minus into minus 0.77, which is gonna give us 1.11 volts. So mostly this is the calculation. This is the calculations that you're gonna mostly need to be able to derive or to answer, because most of the time they can ask you for the cell potentials of a particular cell. So far, do you understand?
Yes, sir.
Yeah, so I think these are all the basics of electrochemistry that you guys are gonna use, as far as I know. So if you don't mind, can we just log into the next session and then maybe go through some simple questions, or maybe like, did they give you guys homework or something like that?
We don't have homework, sir.
So did your teacher give you like examples?
Not to do by ourselves, but we did do some stuff in class, sir.
Okay. No problem. For now, I'm just gonna